I'm Rick Levin, the president of Yale University, and it is with the greatest pride and enthusiasm that I am here to introduce you to Tom Steitz, the winner of the 2009 Nobel Prize in Chemistry. Tom Steitz came to Yale in 1970 as an assistant professor after training at Harvard and the University of Cambridge, and he has been a leading figure in the sciences at Yale for his entire career, for that entire period. He's a towering figure in the field of structural biology, and the prize that he's been awarded honors work that he carried out over a long period of time to identify the crystal structure of the ribosome, one of the most challenging and difficult problems in molecular science. Tom's contributions at Yale span the range from having been department chair to having been a leader, trainer of great students and a devoted citizen of the university. We've all been waiting for this for many years, as Tom's great work was initially published in 1998 and then in 2000 on the ribosome, and it takes the Nobel Prize Committee a little time to figure these things out, but we were confident that they would come around at some point and recognize the extraordinary work that he has done. I want to recognize also, before I turn the microphone over to Tom, that this is a well-supported scientist. He has colleagues who have been great contributors to the progress of his own work. In particular, Peter Moore, his longtime colleague in the chemistry department here at Yale. And Tom Steitz has a rare family, because his wife Joan is one of the leading scientists at this university as well, a pioneer herself in molecular biochemistry, has served also as chairman of the Department of Molecular Biophysics and Biochemistry, is also a great citizen of the university, and is also someone who we hope someday will get the same recognition that Tom has gotten today. Joan Steitz, thank you. It's a great pleasure for me to introduce to you then to Professor Tom Steitz.
Well, it's a pleasure to be here, of course. Thank you all for coming. It's a very exciting moment. And I have to start out by saying how much I owe to Yale and how much I owe to my colleagues. Rick Levin mentioned Peter Moore, and I'd like to mention Peter as well, because he's been a friend and colleague and co-worker and co-collaborator for many, many years, and certainly on the ribosome. So I very much appreciate his company and his work and his participation. There are lots of others, of course, who've been important over the years in the department. I remember Fred Richards, who was the person who hired both of us, as well as Peter, as well as Don Engelman, as well as many others in the department. And I'm so sorry that he died in January, so he couldn't be here, because I would like to share this moment with him, because I credit so much to Fred. But it's been a wonderful environment, and it's been just a true adventure to see structural biology develop at Yale and to be able to work on all these exciting problems that we've been studying over the years, and finally culminating in 2000 with the structure of the large ribosomal subunit. And I have to say that was an exciting moment, because while we were seeking this as a quest, we tried for a number of years. We started in 1995, and it seemed to us a bit like trying to climb Mount Everest. That is, we knew it was doable in principle, but we didn't know actually whether we were going to be able to get there. And we didn't know exactly the route through which we should travel, but we found the right way. And then when we got to the top in 2000, it was very exhilarating. In fact, the most exhilarating moment I've had in science to peer into the inner workings of the ribosome and think about how it works. And our goal in working on the ribosome was to understand the basic molecular biology and biochemistry. I've always been interested in basic research, and I think this is what the NIH does and should support. But it has, as so often is the case, practical consequences, often unseen. I don't think, well, I, for one, wasn't thinking about the ribosome as being a target of antibiotics and that this would be useful. That never crossed my mind. But then we did realize that this was the case, and we looked at the structures of antibiotic complexes. And then Peter Moore and several others helped Finex to help to found the company Ribex Pharmaceuticals, which is located in 300 George Street, and the CEO is Susan Froschauer. And they've been working very hard over the last number of years to use our structural information plus information that they've been able to get subsequently to design new compounds that might serve as active antibiotics. And I have to say they've been extraordinarily successful, much more than I had anticipated. One always worries whether these things are going to work, but they've done a spectacular job. And so I think they are going to have antibiotics that will be active against methicillin-resistant Staph aureus, MRSA. That they have the compounds already, and one has finished phase 2 clinical trials, and hopefully it'll make it through phase 3 and then be out there in the world. So I think it's important to have practical applications of research, but I think one has to realize how important basic research is to get started, and then stuff happens, much of it very interesting.
I'm going to make a layperson suggestion to the press people here. If you go to either the Nobel Prize website or to Tom's 2000 article in Science, you see the picture of this thing. And you know, for a layperson, it's amazing to think anybody could figure this out. I mean, a ribosome is immensely complicated. It's a great big structure with lots and lots of things in it. And the idea that you could infer exactly what the atomic structure of this thing is, you know, it's like a giant mystery. It's an amazing piece of work. I think you get an appreciation. Just look at the picture of what Professor Stites and Professor Moore and their colleagues have managed to do. It's just fundamental, sweat it out, figure it out, you know, science. It's like solving a gigantic jigsaw puzzle about one of the most important, fundamental, you know, aspects of biology, because after all, this is the protein machine. This is the factory that makes the proteins that are the source of life for all of us. So it's a fabulous accomplishment. We're so proud and pleased that Professor Stites and Yale have been recognized today. Thank you all for coming. Thank you.